Welcome to Introduction to Venn Diagrams. I want to go through a few problems with you so you understand how Venn diagrams work. Typically, you're given problems in statistics and they're very terse in the type of information you're given. Suppose you're given the probability of event A is 0.4, the probability of event B is 0.6, the probability of A and B is 0.3, and this is all the information you are given. Now, in typical problems, we won't say event A, B, they'll be using words, but right now we're trying to figure out how Venn diagrams work. So we start up with the sample space, the most important thing in all of probability and statistics. We're going to represent the sample space by a rectangle. This is the whole. This is everything. Now, these simple events, these events that we're given, are going to be represented by ovals or circles or some other shape. So I have the probability of A, the probability of B. So I'm going to draw some shapes, and these circles or areas represent the probability of A and the probability of B. Now, let's look at what the probability of A is in this picture. If I wanted to shade in the probability of A, where is it in this picture? Now, it's going to be a very important thing for us to discover. This is very important. If you don't understand what part of this picture represents this, then you won't be able to do a lot of the problems. So where is the probability of A? The entire circle that's A represents the probability of A. So then what must be the probability of B? Take a second, pause, and see if you can figure out what is the probability of B. If you shaded the entire circle with B in it, you are correct. Okay, let's look at the next one. What is the probability of A and B? Where is it in this circle? Now remember what the and means. The and means what is common to both. So what area is common to both A and B? If you shaded this, you are correct. It's the overlapping region. Okay, so now let's look at a few more other things. You're given these three to start off with. Suppose you're asked to find the probability of the following. What is the probability of not A? Where is not A in this picture? If you shaded in this area, you are correct. The probability of not A is everything outside the circle A. Now, how would you calculate the probability of not A? So hopefully, you subtract from 1.4, 0.4 being the probability of A, I want everything else except that. So 1 is the whole, it's a rectangle, subtract that, and you get your result. Let's look at another one. What is the probability of A or B? Now the or, it's not an exclusive or. The or means the probability of A, or maybe B, or possibly both. So the or just says that as long as you satisfy at least one of them, you're fine. So where is the probability of A or B? Take a second and see if you can shade in the correct area. Hopefully you shaded this entire region. This is A or B, and you'll notice that A or B includes the overlap, A and B. Now, here's the tricky part. Let's say I want to calculate the probability of A or B. What must I do to calculate the probability of A or B? Now I claim you only need the numbers that are given to you right now. This whole circle is the probability of A. This whole circle is the probability of B. And actually it's not a circle, it's a kind of an oval, egg-shaped. Now, what's happening here is the center has been counted twice. So if I decide, for example, to add 0.4 and 0.6 to calculate the probability of A or B, I've counted the center here twice. To correct that, I'll need to subtract the center once, the probability of A and B. The result is the following. Add probability of A plus the probability of B, subtract what's common, and here you have it. Now, just to make clear of something before we actually go to the next one, here's what I'd like to show you. 0.4 for the probability of A already contains the 0.3, which is the overlap. So for example, let me break this whole thing down. The probability of A and B is 0.3. Where is it in the picture exactly? It's right here in the center. But the 0.4 for the probability of A already contains the 0.3 in it. So if I were to look at just the probability of A without the center, the overlap, that would just be 0.1. And if I look at the probability of B, the probability of B is 0.6, but that 0.6 also includes the 0.3 again. If I just look at the probability of B without that overlap, the center, then that region is just going to be 0.3. So to make up B in its entirety is going to be the 0.3 from the overlap and the 0.3 from just B exclusive. Okay, how about this one? What's the probability of not A and B? See if you can shade in the correct area. Okay, hopefully you shaded this. This is the probability of not A and B. Now again, go through each region. Here's what you need to do. Is this region right here not A? No, that's not the case. And remember, this is an AND. I need to satisfy both. Is it B? No. So this is definitely not correct. But since it's AND, I only need to fail once and then I move on. What about this region? Is this region B, for example? Yes, this region is B right here. Is it not A? Nope. That doesn't meet the criteria, so I move on to the next one. Is this region B? Yes, satisfy one again. Is this region not A? Yes, I satisfy both, so this is correct. I only got one more region to go. Is this region here not A? Yes, it is. What about B? No. So this is the only region that gets shaded. Now, how do I calculate the actual probability of not A and B? Again, take a second to see if you can figure out what to add or subtract here. Hopefully, you did this. Take the 0.6, which is the probability of B, and subtract the overlap, which is the 0.3. How about this one? Not A and not B. Again, see if you can figure out what to shade. And go through each region, and again, this is the AND. So the AND's a little different. It means that I need to satisfy both simultaneously. Okay, let's see if you got it. Does this region right here include not A? No. So I move on. What about this region here? Does that include not A? Nope. So then I move on again. What about this region? Does this include not A? Yes. But I'm not done because I need to also satisfy not B. Is this region not B? No. Okay, I need to move on. So now here I'm at the last region, outside here. Is this region not A? Yes. Is this region not B? Yes. This must be it. Now that I've figured out what it is that I'm after, all I need to do is, how do I get the answer that I'm looking at here with this, on this graph? Again, take a second and see if you can figure out what to grab. Okay, this is a little more tricky. In that I recognize that the white space here, the one that's not shaded yellow, is the probability of A or B. So I don't have this sitting in front of me. It was a few slides back, but I can reconstruct it. The A or B is going to be the 0.4 plus the 0.6 minus the 0.3. But of course, that white region is not what I want. It's the yellow one. The yellow is everything else. So if I subtract from 1, I'll get what I want. See again if you can see this one. Notice now I change it back to an OR. What's the probability of not A or not B? Take a second and see if you can shade in the correct area. Remember, OR is a little more looser. I don't have to satisfy both. I just need to satisfy one of them. If I satisfy both, that's okay too. Again, so now I'll go through each region. Is this not A? No. Is this not B? Yes. So this is okay. Is this region not A? No. Is this region not B? No. So I move on. That doesn't get shaded. What about here? Is this not A? Yes. So wonderful. This will get shaded. Again, I don't have to check the other one because this is an OR. All I need to do is satisfy one and I move on. Is this region not A? Yes. Perfect. We shade this in as well. I don't need to check the other one because as soon as I satisfy one, I'm done. So it turns out that what I need to shade is this. Now again, how do I get now that probability? It's just a matter of figuring out what I need to add or subtract. And here's how I came up with this. There's other ways of doing it, but here's how I did it. I see that it's everything except the AND region, so 1 minus 0.3 gives me 0.7, the most direct route. Now let's try this one. What's the probability of not A or B? See again if you can shade in the correct area. Hopefully you shaded in this. Check to see why it is that I shaded this region. And again, if I want to calculate now the probability, here's what I've done. Try it on your own first before I move on. You could pause the video. Now here's my answer. Notice what I decided to do was calculate the probability of A without the overlap. Exclusively A. And then once I've done that, definitely that's the region I don't want. So everything else is what I do want. So subtract that from 1 and I get what I want. I hope this helps, and view this as often as you need to.